conference for you? Was it good? Woohoo! Very good, very good. Love it. Right, so we're gonna try to fit this into the 45 minutes because this is the last one, and I don't want to keep you more into the evening. We're gonna talk about test containers. We're gonna talk about a modules system for test containers, and I would like to show you some practical examples about or little code snippets about what you need to sort of understand, or pieces of code that you'd be happy you have seen before if you would start making your own test containers modules. How many of you use test containers? Very good, perfect. I didn't expect anything else, because why would you be at this more advanced session if you don't use it? Though we're gonna do a very, very quick recap still for right. We're gonna do a very quick recap. Come on, internet. Is it? Slideshow? This is the first time I see this. There is internet, right? It loads. Okay, we're gonna do hotspot. Stay with me. Right, we're gonna just do hotspot. In a second, the trusted iPhone. Come on, technology. This is 5G. You're supposed to be. Well, right. We don't need actually many slides. We're gonna look at the slides in this very, well, the images are not loading. Right. Okay. That don't matter. Doesn't matter. Well, it actually matters a little bit because I need to be able to run containers. Right. Doesn't matter. Test containers. Right. Library gives you programmatic API to do things with containers. You can run anything that runs in a Docker container normally using the programmatic API, and you get the lifecycle API, you get the configuration API for both the container parts, like, oh, which ports you need to expose, or which files you can put somewhere, or executing commands, or running logs. And you also get this whole system of abstraction, which is being in the code is very, very good for many things. For example, for sharing functionality with other pieces of code or with other colleagues in the form of libraries. And this is exactly what test containers modules are giving us. Another hotspot? I don't know. I even have a cable here, so. Okay, cool. Now it works. Perfection. Right. Okay, Wi-Fi. The cable was what was making it wrong. Right, anyway. So, dependencies, you run your tests. The tests create the containers. The test containers takes the care of destroying the containers and clean up. Everything is aimed at giving you the best practices and nudge you into the way of running tests. And it's really, really good. It's way better than other options of writing tests, like, for example, mocks, which are hard to get right and require quite a bit of effort. And I saw this very recently, where Kafka migrated from EasyMock and PowerMock to Mockito, and that took like 5 years. I don't know what the lesson here is, but I feel like there is a lesson. And in general, test containers allows you to have like those higher level integration tests, and they avoid being tightly coupled with your code and avoid various false negatives and false positives of embedded technologies. So it is very, very good. And why test containers is, well, the libraries themselves are great, but like what made it super, super popular is the module ecosystem. Right? The module ecosystem are the pre-built abstractions that give you the power to run any technologies that you want with just a few lines of code. And I personally believe this is what made the libraries and the approach so popular, because as an application developer, I don't have time, or I don't want to understand how to run a particular thing in a container. I don't want to mess with like a wallpaper size configuration using property files or properties or YAML or anything like this. I just want to say, like, give me Kafka and get my Kafka and be happy about that. So, and today we're going to talk about how to create those. And it is very, very interesting both for creating the modules in-house, if you are in the platform team, or if you are in a more sort of senior experienced position where you can give others sort of a paved road into how to write tests with test containers by providing the pre-built abstraction for your technologies. Having in-house modules are great for this, right? If you have any particular configuration, how you run, I don't know, Cassandra, because you run Cassandra in production, building that into a module and giving all the other developers on your team or in different teams in the whole departments and the whole company peace of mind that they don't need to reinvent this goes a long way. So, and also you can build modules and build test container things into different frameworks, and we're going to have an example how it integrates with Spring Boot as well later. So, without further ado, my name is Oleg Šelajev. I work at Docker. I joined Docker after the acquisition of the Atomic George startup, who maintain test containers, and I continue being developer advocate. So don't judge me for my code writing skills, but this is what we're gonna try to do, right? So let's go. We want to go through a number of examples for what it means to create a module, and I want you to kind of sort of give you the tools to understand what is possible and how to achieve certain things. So the first example that I want to show is we're going to create a container for Supabase. How many of you know what Supabase is? It's like a database, and they have a managed service, right? They're like a cloud database that is good for something. I don't know what their marketing pitch is, but like people are using it, and of course, for testing, you would prefer to have a local setup, so you don't want to always go and connect to the cloud instance and manage resources there whenever you want to run like a unit test for the thing. So you'd like to have a local thing. So and Supabase is based on Postgres, so they use Postgres as an internal technology, and they also have the Postgres Docker images that they provide that are, like they say, are compatible and you can use for local development and testing. So naturally, what you can do is create a test containers module for that. So this is what we do. You create a container, you create a class, and you put it in your main class path, because that's going to be a library that other people are going to put on their own test class path. And you extend the generic container. Generic container is, of course, the base abstraction that knows everything how to do what you can do with containers. Generic container offers you the lifecycle methods like start and stop and all other things to do with containers. So you extend the generic container, you use this recursive generic pattern for your class, and then you just need to configure the Supabase container to run Supabase images rather than anything else. The patterns there that are important for us right now is you override the constructor, you try to limit which images people can pass into the constructor when they're gonna instantiate this. So this is important. you require normally, at least we require, you in your company might not, if you are using predefined versions, you don't have to ask for the Docker image name. We on our end always require end users provide their own Docker images, names for those, because we cannot build it in, because that is a security risk, because any default will be seen as the, oh, you by default recommend like Mongo 5, which is like several years old, and probably those images, if they are not supported anymore, they are full of vulnerabilities. So either we need to track and release new versions every time there is a security vulnerability. And I'm not saying Mongo is particularly vulnerable. I'm just saying whatever technology you're putting in containers, there will be security vulnerabilities discovered. So you require the Docker image name to be passed from the outside, and you assert them being compatible with something that you want to support. So when we are building a wrapper for Supabase containers, right, it is reasonable to expect that it's going to work for maybe several versions of Supabase containers, or for custom Supabase container images that people will provide in-house, for example, with additional observability metrics or something. But the shape of the technology within the image, within the container, should look the same, right? If our wrapper is going to run some scripts, or if our wrapper is going to do something else, like, we better expect that those scripts are there. So to avoid situations where people pass, like, I don't know, Kafka images into the Supabase container wrapper, you require the compatibility. And then it will fail early and say, like, no, 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 I only want that. Then you provide any default configuration that you want. For example, here we expose the ports, which is the default Postgres port. And then we configure, for example, the password for the Supabase using the environment. And then we need to also provide the waiting strategy. The waiting strategy is a very interesting thing. The container as a primitive has a lifecycle, right? You can start a container, and the container, when the start call returns, container is started. At that point, the database or the system in container might not be ready yet. And you don't want to return the control flow back to the user, because they will start like spamming it with requests or sending queries to it, and the system is not ready yet. And then it's going to be your problem. Or it's going to be our problem in case of our modules. So waiting strategy provides you with the API to wait for the software in the container also being ready. There are a number of ways that you can organize this. The most typical are for waiting for a port to be available, right? If it's a network software. The second is when a certain command can be executed within the container. And then this little waiting strategy abstraction, waiting for, will run the command there and check until the results are positive. And the most robust is perhaps the waiting for the log messages from within the container logs. So if you're running Oracle database in the container, eventually it will start and say like Oracle ready. And then after that, it's ready to accept connections. Well, usually before that, right? So if you wait for the log lines, then it's good. Sometimes you need to wait for log lines more than once, as in the case with Postgres, because it restarts in the middle. It runs once, ready to accept connections, and then restarts. Why does it do that? I don't know. But we can say wait for the log message, database is ready, appear 2 times. And then it's actually ready. And then, so once you have that, you have the lifecycle, because that comes from the generic container, and this is the most basic thing that you can run, and it's perfectly capable. What you want to add after that, you want to add the convenience APIs, right? You want to add those things which actually make the life of your end users better. So for example, if it's a database thing, the JDBC URL, or if there are any sort of configuration options that you want to expose to your users during the lifecycle of the container, you also can do that using the convenience API. This is very underrated, but it's very, very useful, because then it allows people not read documentation, which is a very important thing, because developers will not read documentation. How many of you like reading documentation? Be honest with yourself. Very good. You're better than, I would say, at least 80% of developer population. Now, what developers would do, we would just do something like this. We'd do this and then like see what the IDE suggests us to do. If it's not in the IDE, it might as well not exist. Because if I have my IDE, I can build things according to my vision of what needs to be done. And then I will build some sort of abstractions, and they're Frankensteins instead of reading docs. So it's always better to expose actually things through the API. So here, this is the basic thing, right? You also, a personal advice, if you're building something, just look at the other technologies that are similar to this. We're building super-based container, take a look at Postgres. You are building the, I don't know, like something for RabbitMQ, which is a message broker. Look at Kafka, or look at something else, HiveMQ container. There are a ton of them available online, so just take a look at that. And then when you have this, don't forget that you need to also have some tests. The tests are fairly simple, but the tests are doing exactly what people will be doing. Creates the container, says that we're going to run this, starts it, and tries to connect and do the basic operations. Usually, the very basic thing like this is enough. And then when you run that, you will get the feedback whether your container implementation actually works, whether it starts, and whether the commands configuration that you created makes any sense for the images that you're going to run. And in generally, don't forget about the tests for this, even though you are building like a test utility. And now we're going to do a little bit of an enhancement here. Even though we're gonna override some configuration, because nobody wants those environment variables to provide additional things. So we're gonna try to override the password here, right, and make it dynamic. So we do that. We create password. We say private string password, and we do this password equals password, and then return this. Perfect. I think that was a full line completion, which is my favorite completion right now. I don't use the chat things. I don't use the AI assistants or Copilot or anything like this. Never sat right with me yet. Right. So we use this fluent builder pattern, and that's why we did this generic container of referential itself, because that's what supports the builder. We put the passwords in, and now we can override the password. Now remember this thing, right? What happens with this? Because in the container, in the constructor, we don't yet have the password. The password will be specified later. So we move it from here and put it into the configure method. So we call super configure, and then we do this with env, and then we do this password thing. So during the configure call in the lifecycle, in general, there is like the full is container is starting, container is started, container is stopping, container is stopped. The whole lifecycle with hooks that you can use, and configure is the first of them. So here we can put the configuration for any options that are provided through builder patterns. So, and with that, we can run this several second more complex test that specifies the password, connects with the password, and also checks that the password was correct, which one we specified. So this is what the basic image looks like. Basic container, basic test containers module, sorry, looks like. Overrides and provides the configuration for the Docker images. For the in-house things, you really can do also the no Docker image name thing, especially when you do this. And then a very convenient thing is you can put here your company sort of registry, right? Because very often people have internal Docker registries, right? And if there are a number of ways how you can configure the tests to use particular internal registries, but having it pre-built in your in-house abstractions is the easiest way, right? You're just saying like, run Supabase container. This is my pre-built image, and then it works. And you can, for example, here just require the version, like tag or something like this, right? And then build an abstraction for this. It's a little bit less convenient for us in the open source, so we don't do that very, very much. Now, the second thing is, after you can run things that don't require any configurations, let's look how you can, with the idioms and the patterns for overriding the commands for the images. Because you do want to run the actual images that you're going to use in production, right? Or at least as close to that as possible for the environment parity. But very often you also want to provide some additional config how you start them, either by adding some development time flags, or like reducing, like making the temporary file system in the RAM disk rather than on the drive, because it's faster. And in general, there is this very, 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 very interesting pattern where we want to provide the scripts. So here's a MongoDB container, which is a copy of an actual MongoDB container. And it does everything already, and that it works, and it works in the default mode, but it doesn't work with sharding yet. We do have the configuration option for enabling sharding. So we have this Boolean there. We can enable the sharding, but we are not using it yet, right? If sharding is not enabled, we run it normally as if we would run it. But if sharding is enabled, we need to run something else. And in this particular case, we need the container to start with this shell script, whatever it is, right? So how do we do this? How do we put a dynamic script, which potentially has dynamic configuration, into the container and make it work, make it run? This is fairly straightforward. You identify the location where you want to put the starter script into. Yes, you identify the container, and then I'm going to copy those two things because we are a little bit out of time. So here's the thing. Once you identify the script, when the container is starting, what we want to do, we want to copy our script into the container, right? This is what we do. This will ensure that the script file from the outside is going to be put into the container during the lifecycle very early in the starting phase, before we actually call the actual command that we want to execute. So this allows us to provide any dynamic configuration into this thing that we need, and it puts it on the predefined path within the container. And then the other part is that with sharding, when we need to enable this, we do this idiom. We set the entry point for the shell, and then we set the command for waiting for the script to be there. And if the starter script is not there, we sleep. But when the starter script appears, we execute that. This combination makes sure that when the container is starting, it will not actually start executing random things, and it will not fail even if you need to put quite a bit of information into the container. So we sleep, and then the script appears, and then we execute that. And with that, we can do any custom configuration for the things. So when the custom configuration is done, the next what you can do, you can build ensembles of containers and put them behind a single facade of pretending to be a single Testcontainer container. For example, when you usually start containers, they will get on the bridge network, and they will see each other by IP, and they will not see each other by the host name. So that's a little bit awkward. So with Testcontainers, you can create the network, and you can put multiple containers on the same network. And then the containers on the same network will see each other by the domain, by the actual host name. So what in this example, what we do, we create the Kafka container, we create a kcat container, which is the tool for working with the Kafka messages. We don't bother even for creating a module for this. We just say like, oh, run kcat, and then run the, we don't want it to do anything, right? We just want it to run and preserve in the running state, because it has some tooling for us. So we just say, run the tail on dev null, which will never return, right? It will tail dev null. So it will create the container from the image, and it will run tail of dev null. So this container will just start and be available for us. And then, of course, we can execute things in containers. So we can, for example, say, oh, kcat, send messages to Kafka. And then we can get, say, like, oh, Kafka is located on that URL. And this is the in Docker URL. So we can directly, and we are sharing the network. So we can use the host name, Kafka there, and we also use the internal ports. Not the external ports that Testcontainers exposes to the host. It doesn't go through the host networks, so you don't see those random get-mapped ports here, but it goes directly to whichever ports are available on the Kafka container, which is those ones. And then we can execute those, and we can have the ensemble of two containers together. If you put it in a module, you can, of course, in the constructor, have like two delegates, right? So, and you can, in addition to your tools, you can also start additional things that you expose to users. When, for example, when you run Supabase container, you can also run, for example, the phpMyAdmin container as well. And then it will work, and multiple containers will start, and the user will be no wiser altogether. Right. Additional thing about networks, what you can do, you can also play with the ToxiProxy container. ToxiProxy is, of course, a tool that messes up with your network on the containers. I have this another project here that we can here. So here's how it goes. I create Postgres, and I can create ToxiProxy. And when I need to configure my application, in this case, this is a Spring application, and I configure the reactive JDBC. I don't give it the Postgres things. I give it the ToxiProxy URL. And then the network in my tests, access to the database, will be through ToxiProxy. And then in my tests, I can do things like, ooh, ToxiProxy, get the toxic for the latency, and like every downstream packet, please add the latency of 1600 milliseconds. So you can build sort of systems where you can check how your applications behave when the other part is slow on the network, which is very hard to test usually because locally everything is fast. And this way you can create those chaos engineering things. And when you're building your own module, right, you can also hide the existence of ToxiProxy there and inject those toxic and latencies and jitters randomly. So when your users will be using your Supabase container, they can be no wiser, but you will inject some latency into all operations at random. Usually it works best when you have a generic SLA for applications should work, even if the database is like 5 seconds slow or something like this. And this will, of course, work for other systems, but you don't require, you might not require your end users to create multiple containers like this, but you can post it behind a single module that looks like a single container. And then all those things just hide behind the convenience API for, well, in this case, R2DBC URL, which is kind of cool. And you can also do actually more things with databases. because test containers gives you the ability, the convenience API, right? It doesn't only have to do with like getting information out of the container. You can also mask operations that users can do with your containers and map them to the API calls. So here I have Postgres module, and it's a normal Postgres modules, but I will use it with the template databases. Template databases, how many of you know template databases? Okay, a few hands. In Postgres, when you create a database, you can say what other database to use as a template, and it will copy the state and the data in the schema into your new database. So by default, it uses an empty database as a template. So when you create new database, it just gets a copy of an empty database. But you also can create a database, fill it with data, and say like, oh, now you are my template. And then when you create other databases, they will get the copy of that one, which could be very convenient for tests if you want to sort of recreate the data. So here's my implementation of this that is not production ready, but it can give you some ideas. So I will initiate my database with a schema for simplicity. I just put a file in there. So my database, my normal Postgres database will be initiated with whatever is in the schema, which is the products. What I do, I added two convenience methods. One is the snapshot. And what the snapshot does, when I call snapshot, right, it runs this pSQL unit user test, and it says like alter database test and mark it as the template. And then I also say, I call the reset, and I say that my database for the container, for this wrapper, is another database, not the test, but real test. And then what reset does is I drop my actual database. So whatever the database I want to test with, I drop it, and I recreated this again, and using the test database as a template, which is exactly that. We create the data, and then we just drop and recreate new database every time we call reset. So, and we do that first time on a snapshot when the container is started. So if I have a test, and my test, for example, uses my Postgres with templates, right? Configures my application. I used Spring here because I couldn't figure out the normal connection details. So I used Spring just to access the database. And then see here what we do. We query for objects, count from products, and we say we expect it to be 3 because the data was there. Then we truncate that and expect it to be 0. And that, of course, works. Because initially when we create the database, the count is 3, and then the count is 0 because we truncate the database easily. And then, so here it's green, right? And then I have this another test here which does exactly the same. It's just a copy. Now, if I run both of them, one of them will, of course, fail because we create the database with data, we verify things, we truncate the database, and we run another test, and whatever the situation, whatever the order was, once we truncated, there is no data. So here what can help us is that we can do before each, we can just say public restart everything. I cannot type, but doesn't matter because we can do pg reset, right? And it's void. So, and if we do it like this, then whatever we do in the test doesn't matter because we reset, we recreate the data. And both tests supposed to be green at this point. What? No, seriously. Wait, why is it not working? What? Sorry. Yes, the snapshot is set here in the container started. Right. So we do the snapshot, and then we call reset once. So it's supposed to be like all good. Wait, why? Okay, let's do when everything else fails. What we need to do, we need to read the README, the docs. Right, no, this is supposed to be correct. Wait, can we run one? It doesn't matter. We're slowly getting out of time. I want to show you two more things. It was supposed to work. It worked. I've seen it. No, it doesn't. Yes, it's almost 5. Let's go. I don't know. It's like it is tired. It is tired. Right. So another module, module 6. What I want to show you here is, you know how there was a session about AI here before, right? And then you can use your AI and call to ChatGPT or something online. Well, there is a local thing called a llama that you can use to run models locally on your machine. And one of the best ways to run a llama is, of course, in a Docker container, because why not? And what also you can do, if you can run it in a Docker container, you can wrap it in a Testcontainers module. So, and why I'm telling you this, because you can't spell, everything needs to be about AI nowadays. These days, it's very important. And you can't spell Testcontainers without AI. It's right there, look. So, so here, but no, it's actually not about that. So, when you create modules, you cannot only work with the images, but you also can work with the Docker primitives that you want to run. For example, you can add additional, you can modify the container creation commands, and for example, add the capabilities for the devices. So here, when we run a llama, we really want to give it an access to GPU, if we can. So here we embed that information in the container configuration, and we say, like, if we are running with NVIDIA where we can get the GPU access, please modify that. So when my container is started, right, this is the lower level Docker client API, not the Testcontainers API, which is directly going to Docker, right? And then run it with the GPU capabilities. And then you can run it and you have access to GPU. And you can also use that to limit the amount of resources your modules, your containers are getting access to, which is very convenient if you need to either have the predictable performance environment or anything like this. So here's an example. I run my Java 17 in a container, and I limit the memory that it gets, and I limit the CPU that it gets. And I run the tests, and one of them gives 1791 memory and expects the serial GC to be picked, and the other one gets a little bit more memory and expects G1 GC to be picked. So what we do, we run that Java container, we just print flags from the Java command, and we get the logs, and we assert that our logs have the pattern for the GC depending on what GC was picked. Right, so when I run this definitely should be green. Like, this is the very simple one. But like what it will do, it will limit the container configuration, and then it will run. Okay, perfect. Both of them are green. How lovely. So now you know that your Java selects the GC based on the resources. It's very, very convenient if you need to run like some very greedy technologies that are usually are intended to run in production. Because in production, nobody runs stuff in the shared VMs, right? Like everything gets, so you run a container or something, and usually it can be configured to get all the resources that it has access to. Because like in production, you limit it on other levels. In development, it's not like that, because it's like a little bit silly to allow my Elasticsearch or my Oracle database eat all the resources of my machine, because, well, I need to run other things. I need to run Slack on this. and my IDE and so on. But you can do this. You can do this. And the last one, for which we have just 1 minute, well, it's one to last. This is how to integrate Testcontainers module into the Spring ecosystem. So here's an application, and this is the application. It talks to GitHub. It talks to GitHub, and in our application test, we don't want to go to GitHub, so we create the wire mock container, and we specify some mocked data in the wire mock container, like, for example, what the answers should be. And of course, we need to configure it with the dynamic property source, but this is boring. We don't want to do that. We want to have the service connection on this. The service connection works like this. In our main application somewhere, we have a class called container connection details factory, which is the container connection details factory. And it takes the wire mock container that we provide, and it produces the GitHub connection details in this case, right? And it's very simple. We literally say which data we need, which properties we need to set, and we use the container to provide that from within the container data. And then this, of course, would not work out of the box because the Spring doesn't know anything about the connection properties yet for us, right? Come on, fail. Fail fast. And what's the wiring mechanism? How do we tell Spring that that wire mock connection details factory is supposed to be in use? We use the Spring factories meta information, and which says that auto-configure connection service connection details, use our class for that. And if that file is available, then all the pieces fall into place. Our wire mock container starts. Spring finds that auto connection details factory. The connection details factory provides the connection details out of the containers, and the service connection wires it all together so it works. So if you are building modules that are intended to use within Spring Boot, consider also adding that connection factory thing so people can configure it with the minimal effort. That's it. We're out of time. What I also wanted to show you is that you can run not only like databases and stuff, but also sort of development time tools in your containers, like that just help you do something. If you run a Kubernetes cluster, you can run K9s as a tool, or in my example, you can run the Cloudflare worker to share your application online on the random URL if you want to share that with your friends. But for that, you will have to read the docs yourself. There are a couple of links. The examples are available on the Java module workshop on Testcontainers. I used the Testcontainers desktop. All my containers were running in the cloud. That's how it managed to pull them all so quickly. So you can check it out with testcontainers.com/desktop. It's a free application. And if you have any questions, please join the Slack. Maintainers are there. The ton of our community is there. And we will be able to answer all your questions and help you with any Testcontainers inquiries. Thank you very much.